We are going to reinforce the basic idea of exponential equation using more examples. Okay, so in example 4, you're going to see two fractions. You are seeing some fractions and decimal. So when we see fractions, we will try to relate to this the indices rule for fraction. Okay, so let's talk about A. So in part A, okay, we got a 3 power x. Okay, then we got a 1 over 27. So first of all, you need the instinct that 27 is 3 cubed. You can punch your calculator to confirm the value. So 27 is 3 cubed. You got to automatically change it. And then you can relate this rule here. So once you relate this rule, you'll be 3 to the power minus 3. And you will end up with the same power. Sorry, same base. So where we got the same base, we can compare the power. So from the comparison of power, my x is equal to minus 3. So that's how we present it. Okay, for part B, you are also going to see a fraction there. Okay, so before you swap anything regarding the fraction, so is there anything special about the number 8 or 16? So the instinct will be 8 is actually 2 cubed. Okay, 16 is actually 2 to the power 4. So you realize that they have a common base. Okay, then, okay, again, I will swap this rule here. So when I do this rule, the next thing, right, I will see is I will hit the double power rule. So if you still remember, there's a power inside, there's a power outside. So the rule says that you're supposed to multiply. So again, you hit the idea of same base, which allow you to compare the power. So when you compare the power, you get the So for part C, you actually got a decimal. So when you got a decimal, change it to a fraction first. So in this case, it'll be 1 over 1000. So when you change it, 1000 is 10 cubed. So all these have to come from the awareness. You can just punch calculator. But after a while, you realize that these are the frequent number that always appear. So you apply the rule and you will get a 10 minus 3. And then that gets you to the same base. So which allow you to compare the power. Okay, so example 4, if you realize we rely a lot on the rules that convert fraction. Okay, so if you go on to example 5, we actually got more rules. Okay, so in example 5, let's talk about A. So when at the first glance, they are all different base. So I think just now, in one of the previous example, I mentioned that 1 is you can use the power 0 rule. 1 is flexible enough for me to change to any base that I want. So in this case, right, I'm going to look at it in this way. So 27 is actually 3 cubed. So I change out the 27 to 3 cubed, and with the double power, I actually get the power of 3x. And here I can change it to 3 to the power 0. So the rule that I'm using is this one. So it can be any base that we want. And then this will be the same base multiplication, rule number 1. So rule number 1 allow me to add the power. And then I eventually got the same base. So you go and compare the power, you get the x. Okay, so there will be a bit more rules, same base multiplication. In part B, we actually got a same base division. So this 1 over 25. Again, when you see fraction, it comes back to the rule. This part. It comes back to this rule. So how is 1 over 25 related to this rule? So it is 1 over 5 square. 1 over 5 square is 5 minus 2. So this is same base division. So this is your rule number 2. So rule number 2 says that you're supposed to subtract. So I end up same base. And therefore, my x is 16. Okay, so that's how we go about playing around this kind of thing. So in part C, the base we are having will be 8, 16, and 2. So first of all, do you realize that 8 is 2 cubed? And do you realize that 16 is 2 4? So if you realize that you do a double power, you do a multiplication to the power. So upon doing the multiplication, you end up having same base multiplication. So when you do a same base multiplication, you add the power. So eventually it will lead you to the same base. And then x is equal to 6. So there will be a mixture of the rules that you will need to apply before you can come to the foundation method, same base, compare power. So that will be how good you twist all the rules that you have. Okay, so let's look at example 6. Okay, in example 6a, the number could look quite huge, 3243. So you can punch calculator. So just try to random press calculator. You realize that it's 3 power 5. So even though the number is quite big, okay, you have to punch calculator to play around. So you lead you to the same base, and then you compare the power. So it follows. So subsequently, it's just your basic algebra. So in part B, you see a lot of base 2, base 4, base 8. But all these number has a common property. So I can change 4 to 2 square. I can change 8 to 2 cube. And in fact, I got to do the double power rule here. So I got to multiply the power. And then this is same base one more time, same base multiplication. So let's execute the same base multiplication by adding the power. So here I'm going to do an open bracket. So I expand out the bracket. So all in all, you will realize that you actually get a very simple power to compare, simple base. So upon same base, you compare the power. So if you do a comparing of powers, this part, 3x plus 3 will be equal to this. So that becomes your typical algebra. It's just very simple algebra. It looks complex, but it's not that much. Okay, so here comes the tricky thing. So in example 7 and 8, the question looks shorter, but it can get more challenging. Maybe this one not so challenging. So a lot of people, when they first see question, example 7, so they didn't know what to do with the 4, because 4 cannot be multiplied with 3 to the power of x. So it's actually different base. So there's nothing you can do. So what to do with the 4? You can divide 4 on both sides. So in a way, you divide both sides by 4. So think along that line. So or you can think about dividing by 4 over. So when you do that, you actually get a very simple number. So simple that you can even mental that there's a 3 square and same base, and you can compare the power. So it's actually not that difficult. Okay. Okay, the next one looks a little bit complex, but it's actually not. Okay, so let's explore the multiplication and the division. Okay, so for the square root portion, you need to recap that the rule for square root will be a power half. Okay, it's not very complex because actually everything is same base. So if you want to do same base multiplication first, you can just add the power. After you add the power, you realize that you are faced with same base division. So same base division, rule number 2, I've got to subtract the power. So eventually I come to same base. In this case, the base is algebra, but we are not supposed to find x. We are supposed to find m. So it will still be same base and you compare power. Okay, but in between you got to execute quite a lot of rules so you can get you to the foundation idea.